Okay, so hi everyone. Myself Pratham Chaudhary from SMEC, and registration number is 21VM11110. So here we are going to discuss the topic that is algorithm classification. So basically, the algorithm classification are classified into two algorithms, that is construction algorithm and improvement algorithms. Okay, so construction algorithms uses the graph-based method, and improvement algorithms uses the pairwise exchange method. So in the graph-based method, we are going to discuss about Aldep and Corelap, and whereas in the pairwise exchange method, we are going to discuss about craft. So let us discuss what is pairwise exchange method. So basically, it is used for layout improvement and distance. It is the distance-based objective. Okay, and like procedure is to calculate total cost for the existing layout. For each iteration, evaluate all feasible exchanges in the location of the department pairs. Select the pairs that result in the largest reduction in the total cost. And if the lowest cost for your next iteration is worse than the total cost of the previous iteration, the procedure is terminated. And so here we are to discuss the craft. Okay, so the formula is m minimum equals sigma. Actually it's double sigma, so it's I equals 1 to m and j equals 1 to m, fij, cij and dij. So here you can see that the procedure to determine the craft is uh, to calculate the rectangular distance between the centroids, calculate transportation cost for the layout, determine the estimated change in the transportation cost for each possible exchange, repeat the procedure for the new layout until no interchange is able to reduce the transportation cost. So basically this all thing is the procedure. Okay, so we will now change to the next slide. So here is one of the example. As you can see here, it is a facility with 7 departments. Okay, and the total cost to carrying any material we will denote it by Cij, and that is equals 1, and each grid size is 20 cross 20, so the total area is 7, and it's about 7200 meter square is available. Okay, and the requirement is 70,000 meter square, so we have left with 2000 meter square. Okay, now as we can see, so the procedure is first determine the centroids, department centroids, calculate the rectilinear distance between the centroids, and calculate transportation cost for the layout. So this basically this thing is a craft. So we are going to discuss the pros and cons. So here are the pros. Like craft is flexible with respect to department shapes. In theory, craft is applicable only to rectangular facilities, and what domain departments are have no flows or interaction with other departments, and requires certain area can be fixed and used for non-rectangular facilities, extra space, building irregularities, fixed areas in the layout, and crafts captures the initial layout with reasonable accuracy. And here we are for the cons. So locally optimal solutions only, so it only provides you with the optimal solution, and craft it may lead to the irregular shapes for both individual departments and the facility itself, and it is not always possible to extend to unequal size adjacent departments without splitting the larger one. So here we are with the Corelap, which uses the graph method. Okay, so so the main feature is it is developed for the mainframe computers, construction types, adjacent basement. Like you have 5 alphabets A, E, I, O, U. So you denote A equals 4, E equals 3, I equals 2, O equals 1, and U equals 0, and X equals -1. So your first priority is A, second is E, third is I, fourth is O, U is fifth, and X is your last priority. Okay, so now here we are with department selections. So the first department placed in the layout is one of the greatest UR value, like with most number of E and most number of A. So first priority is A, so you will calculate that which department has the highest value of A, so that will be your first priority, and you have to sum up the all the E and A values to determine which is your first priority. So we will now take the example. So here it is, here is example 1. Okay, so it is only one example. uh, like here it is department 1, so we'll look for the department 1. We have the number of a equals 0. Okay, as you can see there is no a in the first department, so here it is 0. For e, similar it is 0. For I it is 1 and 2, and for u it is 5. Okay, so likewise we will calculate the for the every department. So what we get is uh, your department your department fifth will get the first priority like placement sequence, and sixth is will be your second placement sequence. So like you can see here, the department fifth had uh, two A's. That's why it is we have given is a priority, and it is in the first placement sequence. Okay, and if you sum of all the elements in the sixth, like it is at 1a, 1e, and 1i, so the priority will be 2. Likewise the priority goes on with 1 to 9, and that's how you decide the priority of in the Corelap. Okay, now we will go to the next slide. We have some comments on the Corelap. So the final layouts are evaluated by the distance based layout score. Corelap uses the shortest selected linear path between the departments, and area are assumed to be on the right side of the department nearest to its neighbor. The layout often result in irregular building shapes, and that's the conclusion for the Corelap. Now we will now head towards the Aldep. Okay, so Aldep is somewhat similar to the Corelap and the objective requirements. Adjacent, it is a adjacency based method. The main differences are randomness, multi-floor capabilities, and a Corelap attempt to produce the best layout. Aldep produces many layouts. That is the main difference. Now we will take some example for the Aldep. So here we are. So how you look is like so the thing is we have 6 alphabets like A, E, I, O, U, and X. So A is values is 64, E is 16, I is 4, O is 1, U is 0, and X is 1024. So here in the question, the given is the dimension of the facility are 10 cross 18. So it's so the multiplication is 180. Now what you do is to divide it by 12,000. You come up with the some what values. Now the thing becomes is 400. Now divide 4,000 by 12,000, you will get 30. Okay, so the thing what becomes is you'll get some values like department 1. Okay, so the 4 department, we will look for the department 4 here. So okay, so basically the thing is department 1 has 30 units. So how we place is uh, the first priority was the department 4, so it comes like in the set of 2. So you will place like 4 4 4 4 4 4 until it becomes a 30. So if you calculate this thing, this all fours, they will become 30. Now the second priority was 2. So you will calculate that how many 2's you need to place. So there are a total of 20 2's. So you will, what you do is start from here and place it likewise until it becomes the total of 20. So if you do like this, your final layout will become somewhat like this, and this is what your Aldep is. Okay, so this is the same thing what I have told you now, and that's conclude my presentation. Thank you.